Okay, so we are live now and recording, and let us just wait
Okay,
for a couple of minutes for everybody to join and
great.
have a founder GDSC lead teach us about time series analysis.
Thank you, Ishan. Thank you very
Yeah,
much.
we'll just send the link to everybody on the WhatsApp groups, and we'll start
Perfect.
in about 5 10 minutes.
Great.
Hello?
Yes, Shivam.
Yeah. ईशान
Uh,
सिमिल अच्छा स्टार्ट कर दिया क्या सिमिलकास्ट मैं चेक करके आता हूँ रिफ्रेश हो रहा है
simulcast has started. Recording has started. Simulcast has started. अभी खाली attendees आएंगे then we'll start.
but on YouTube it is not reflecting. Yeah, it has started, stream has started.
All right, everybody. Let's all welcome our host, our former GDSC lead, and let's get ready for the time series analysis session that he's going to take, Mr. Tushar Sharma. And we all are live again on YouTube. The session is also being recorded, so no need to worry about repeating anything. You can always go back and view the session again. Over to you.
Thank you, Ishan. Thank you very much for the warm welcome. So, hello everybody. Good evening. So today, I remember I used to take a machine learning boot camp in the month of April. That was in 2022, and this year we are up with the new machine learning series organized by GDSC Amity University, Mumbai, and I'm going to be explaining the very interesting topic in AI, which is time series analysis. So basically, let's hop into it. What actually time series analysis means. So let's assume you study in a particular college and you are doing engineering. So definitely you would be liking coffee as such, because we engineers, we have an habit of staying up late at night and then waking up late. That's what I usually used to do in my second and third years. So, for example, let's assume that you drink specific number of coffee mugs every day, and you are in your current semester 6, and you wanted to track that how much cups I'll be consuming later on when I go in semester 8 or I go in semester 7. So, in that particular case, we use time series analysis. So, time series, but predicting a certain value at certain point in time. Now the question will arise that we can simply implement some machine learning algorithm and we can predict this. But the catch is, time series analysis, there is only one particular variable which we call it time, right? It's That's why it's known as time series analysis. In supervised learning, we have two types of variables. One is dependent variable and another one is independent variable. So that's why we are able to find out a relation between them, and then we are predicting our results, right? But in case of time series analysis, there's only one variable. So that's why we cannot use any type of supervised learning algorithms in that. Okay. So what do we usually do in time series analysis is we simply just plot a graph between time and magnitude. In our case, when I considered the example of me drinking a specific number of coffees, for example, I am plotting a graph of the time, for example, starting from January 2022 till May 2022, how many cups of coffee do I drink every day? So that becomes my magnitude, right? 4 cups of coffee, 6 cups of coffee, and many more, right? I plot a graph, and now I want to say that how many cups of coffee will I drink in my semester 8. So using that particular graph and time series analysis algorithms, I'm gonna get my results that okay, in semester 8, I'm gonna drink these many cups of coffee. So this is what time series analysis basically is. It's a statistical method to analyze time dependent data. Our, as it says, our data is actually dependent on time. Time, right? Time is the main variable which we are using in our time series analysis. So moving on, so time series has a specific number of components, or what you can say is three different basic components, which is trend, seasonality, and noise. We'll be talking about this later on, but now just let me tell you what is the importance of time series analysis. Like, why do we actually need it? The first reason is absolutely I want to predict what I'll be doing at certain point in time in the future. It's used for weather forecasting, business forecasting, or if you want to analyze any pattern. Like for example, uh, I am being very sick after drinking so many cups of coffee, and the doctor wants to analyze my coffee drinking pattern so that uh, he knows the reason, that what is the specific reason behind my sickness. Is it of coffee? So in that particular case, I want to analyze my past behavior. So that's why I'll be using this time series analysis to analyze at certain point in time or at a certain day in my semester 6. I have drank around 6 to 8 cups of coffee. That's why I'm becoming sick. That may be the reason. and on that basis the doctor will be prescribing me medicines. Also he'll be restricting my drinking of coffee habit, right? So eventually he wants to plan my future habits. So time series analysis is also used to plan the future. And for example, he wants to analyze my current condition, my current behavior, current habit of drinking coffee. So in that case as well, I can use time series analysis, right, for evaluating my current scenario, right? So now let's move on to the different components of time series analysis. So the first one is trend. Trend is basically like you you have two kinds of trends, basically two to three kinds of trends, which is upward trend, downward trend, and stationary trend. Upward trend simply means that your values are generally going higher and higher and higher, and downward trend, as the word says, it's going downwards, and stationary means it's completely stationary. Okay, so I'll give you a very good example. In Amity, so we have our annual fest, which is Aminova, and I want to make some business in Aminova. So what I usually do is I'll set up a store near the college during Aminova, right? So what will happen is, as soon as Aminova is coming near, so my sales will definitely increase because more number of people wanted to buy clothes from my shop, right? Traditional clothes. So definitely my sales are going to increase. But as soon as Aminova is done, okay, and exams are coming nearby, my sale is generally going to decrease because nobody is going to like buy clothes from me, right? Or probably so till the college goes, some people may buy clothes for me, like from my shop, right? So in that particular case, let's assume that 2 to 3 people are coming to my shop every day. That is after Aminova. And during Aminova, 45, 50 people, 70 people are coming to my shop and my sales are increasing. Okay, first, generally the sales increase till Aminova. Until that, after some time, till exams are there, my sales will be stationary. 2 to 3 people will be coming to my shop. And after Aminova, when there are exams, the exams are over, people are going back to their home for vacations, my sales will generally decrease because there will be no one on the campus. Okay, so that means first, in first case, my the trend is that it is going upward, the sales graph. If I'm plotting a graph of date versus sales, which is the magnitude number of sales per day, so in that particular case the graph will be going completely upward. It will be a upward trend, right? And once Aminova is over, it will be a stationary trend. Stationary as in only few number of people, very less, 2 to 3 will be coming to my shop every day. And after that, it's going to be a horizontal trend, right? So this is what trends mean. That is going upward, going stationary, and going downward. So if you find any such thing in the graph, as you can see in the picture, first the graph is going upward, and then it is going downward, and at some point it is stationary, right? So that what trend actually means. And now let's talk about seasonality. Okay, so seasonality is nothing but it's just like a repeating pattern of going upward and downward. Okay, I'll give you a very good example. Considering our previous example only, there is fest Aminova that is only once a year, right? And that happens in the month of April. And after that, the sales are stationary, and then the sales goes down. So this is going to happen every year. So what does that mean? The same pattern is going to repeat, going upwards, being stationary, and then going downwards, right? The same pattern is going to repeat every year, 2022, 2023. Or other good example is the sales of crackers, right? We usually buy crackers during Diwali. So every year in Diwali season, the sales of all the manufacturers of crackers are going to increase, right? And for the rest of the year, it will be stationary or it will be downwards. But at certain point of time, every year, the sales are going to be higher, right? So that is what we known as seasonality. Season, a specific season where there is a certain repeating pattern, right? And the third one is noise. So you can noise is very simple. You must have heard it in physics that there is some noise in the signal. So what is that noise? It refers to any random fluctuations or any random values. For example, suddenly I there was a case in one of the cafeterias that there was a food infection, and like 40 to 50 people got infected. So at that particular time, there was a medical shop near the campus, and the sales of certain medicines were quite higher at that particular time, only for 1 or 2 days, and then it was normal because more number of people were infected and they were buying that particular medicines. So the number of people coming to that shop for 1 or 2 days was suddenly from 2 to 3 to 100 because more number of people were affected. So only once in time or at any random point the sales went higher. That means the graph is higher. So that means there is some noise in the data. Any random fluctuations or at any point of time, that is known as noise. Okay. So there is one more thing. Now the question must arise that time series analysis are used for predicting some problems, right? Or like if you want to predict our future, at that particular case, we use time series analysis. So in what cases we shouldn't use time series analysis? Like there is no use of using any time series analysis. So one of the case I can say that there is a repeating pattern in the data and we have a function for it. For example, let's consider y is equal to sine x. So everybody knows y is equal to sine x. It's a this kind of curve, sine wave. The pattern keeps repeating. So in that particular case, for example, my coffee drinking patterns is just like a sine curve. Okay, it's similar to sine curve. In that particular case, I don't need to use time series analysis because I can simply find like the magnitude at any particular point or the value at any particular point because it's a repeating pattern, right? And we have a function for it. So in that case, I won't be using time series analysis. I can simply use normal y is equal to sin x function, and for example I want to find the value at 90. So sin 91, right? So that's what is the main thing. We don't need to use time series analysis everywhere. For example, or if the value is constant, for example, it goes up till 5 and then it becomes constant for infinity. For example, I am drinking for 2 cups of coffee every day, and at certain point of time I start drinking 4 cups of coffee for infinity, like until lifetime. So in that particular case, I don't need to use any time series analysis for that. Okay. So let's move on to next time series analysis in Python. So in Python, we use you must have like seen various libraries, and I guess it must have been explained in the bootcamp as well, which are NumPy, Pandas, Matplotlib. Okay, so NumPy and Pandas, you simply know it is used for data manipulation and data cleaning. Matplotlib is used for visualization, and now in time series analysis, there is a specific library which is known as stats models. It is used for statistical modeling and forecasting. So it's a different library where we have different kinds of models. For example, I'll be explaining you arima model, sarima model. So those kind of models are in this library. Okay. So everybody knows how do we read the data in Python, right? Using pd.read underscore csv, right? For analysis. That is pandas library. Okay, so it's like that. And visualizing time series data as in you need to see that what's the pattern of data. For example, as I said, that the curve can be sin x. Okay, so what if your data is just like a sin x curve? Then why should we use time series analysis in that particular case? Or you want to see how much noise is there in your data, how much trend and seasonality is there in your data. So accordingly, you can make changes and you can process your data. So one another terminology in time series decomposition is time series is time series decomposition. Like what in time series decomposition, what you basically do is you decompose by of the process of separating a time series into trend, seasonality, and noise components. Okay, what I told you is these are three basic components or important components for time series analysis, right? And you need to analyze all three of them. So that's why I use time series decomposition. Okay. And there are various statistical models which is in the stats model library, which is arima, sarima. So these kind of models I'll be explaining you it. I'll be basically explaining arima model. Okay. So first you what you do is you basically analyze your entire model using various matplotlib libraries. You take your data in, and then you apply any of these models as per your data, and then you fit your data, and then you get the results. So this is the basic, what I can say, the structure of a time series model. Okay, so now let's get into the coding part. But before that, I'll be sharing something with you all. I'll be sharing the link to a data set which I have used in this. So I hope it is visible to all in the chat. As well as I'll be uploading this on YouTube as well. Um, Ishan, can you please share it on YouTube as well?
Yes, I'm putting it in the stream chat on YouTube.
Perfect, perfect, perfect,
Yep. Yep.
perfect, perfect, perfect. So first of all, let's move into the coding part. I hope my screen is visible. Perfect, perfect, perfect. So this is actually an implementation of ARIMA model. So ARIMA model basically stands for autoregressive and moving average. Okay, autoregressive and moving average, and I stands for integration. So what is autoregressive? So it is basically the correlation between the previous time period to the current. For example, considering our old example of plots of time versus the number of times I am drinking coffee. So let's take a particular time period which is t. Okay, so the correlation between t and t minus 1, it is what we call as autoregressive. Okay, and like, what is moving average? The average of all the noises which are present. Okay, and when we integrate it, so that becomes our ARIMA model. Okay, so there are some, like, some parameters which are there in this ARIMA model, which are PQD. So P is autoregressive and Q is moving average, and D is the order of differentiation. So we basically use this D to make our data to be stable, right? So now let's start executing this. I imported all the libraries, stats models. As I told you, it contains all the models, which is ARIMA, GARIMA, etc. Okay, and yeah, perfect. I have loaded my data, and then now let's load our data set over here. So URL are the web URL and pd.read csv, reading the data using pandas. Yeah, it has been executed. Now I am converting the month into a date time object. Okay, so I want my month data to be in a particular format, which is year and month, right? That particular column should be in that particular format for analysis. So I'm converting it into that, and it's done. Okay, so now I am defining my time series model, which is ARIMA. So you don't, in Python, you don't have to do any such calculations, or there is no specific code for it. You can directly call the the call the model from stats of models, and you can execute it. So model is equal to sm.tsa.arima. Okay, TSA stands for time series analysis. SM is our stats model which I've imported, and I'm importing ARIMA model for passengers, and the order is 111. So now let's do it. And now we are going to fit our data because our model is ready now. Perfect. So now let's see the summary of the entire model. As you can see, it is giving you a bunch of parameters. And now the next part is this. We are generating a forecast for the next 24 months. I'm sorry, it's not 12, it's going to be 24 months. So I want to see whether the forecast of the passengers for the next 24 months. So basically, this data set is like for the passengers at specific point. Okay, I'll just share this. I'll just share my entire screen then. Yeah, just a minute. Yeah, this is the data of month to that of passengers, right? So in this particular case, it will be predicting it for the next couple of days. That is for the next 24 months. So now let's see the results. Yeah, perfect. So I'm gonna focus it for the next 24 months. That's why I've taken the steps to be 24 so that it predicts the next 24 values. As you can see, it is now predicting the next 24 values. So this is how basically it's a very basic ARIMA model. I'm not going in depth because I have to cover the entire, I have to give you an overview of the entire model, right? So now this is for ARIMA. Now let's do it for SARIMA model. Perfect. So the same procedure, importing all the libraries. It's taking some time. Yeah, it has been executed. Same, loading the data set, converting into a datetime object, setting month as the index value, and then what I'm doing is I'm splitting the data set into train and test data. So ilog function is the useful for selecting a particular number of rows and columns from your data set. Now I define my time series model, which is Sarima. I'm fitting my model. It says fitted. Now here's the model summary. It will give you certain results, model, date, type, sample, covariance, all these parameters. And now let's generate some forecasting based on this train model. So forecast equal to results dot forecast. I'm storing it in the variable which is forecast. That's the mean absolute percentage error. If you want to find it out, the error. And here's the forecast. Yeah, it's giving me the values of the next dates, right? So this is basically how the entire the time series analysis works. Okay, so this is more or less like an overview of entire time series analysis. Of course, there are more terms as you go in depth of that. So what I'll be doing is I'll be sharing a small cheat sheet which I basically use for every like session, or if I'm taking any session or if I'm giving any session at that particular time. So I'll share it with you all, and it will be uploaded on GDSC Instagram page. So if you guys have any queries as such, do let me know, so that you can drop GDSC AUM. They'll forward it to me. So thank you GDSC AUM for calling me as a guest speaker. Thank you Ishan, and all the best to the entire team of GDSC for the next sessions. Thank you very much.
Thank you so much. It was a great session, and I believe um, the viewers on YouTube are quite happy. There have been a varying number of viewers on YouTube. However, the attendees on the GDC platform have been constant. So uh, let's see. We'll release the stream link to everybody else again so that they can view our recorded session once again. It's been a wonderful session. And of course, the code itself is available on the screen that you see. So instead of going ahead and copying it, I would urge all the viewers to go ahead and explore on their own, maybe type some of it. So with that, I believe this is time for Shivam to come over and give the vote of thanks and end note.
Yes, thank you, Ishan and Tushar Bhaiya. So, students, once again, thank you for attending our event today. We hope that you found the sessions informative and thought provoking. We trust that you have learned a lot and are now ready to apply your newfound knowledge to real world scenarios. So, as a part of our event, we encourage you to take up a project on your own using any data set that you like and any appropriate algorithm. We would also like you to remind you to use comments to document your project properly. This will help us to understand your work better and provide valuable feedback. And we would also like to inform you that you will receive a message in the group with instructions on how to upload your project. And in the near future, we will also be sharing the link where you can showcase your work to a wider community. Once again, thank you for attending our event, and we look forward to seeing your projects soon.
Thank you so much, Shivam. Once again, just for everybody's information, there are a couple of links in the chat. I'll be sharing them on YouTube as well. Please go through the same, and we'll see you again when you submit your projects. Thank you.
Thank you, everyone. Good luck.